Oxford University's Explanation in Science, and we're going to cover around 40 different topics if we take the previous years as well. And this is a survey from over 200 teachers, 50 students, and it's all the tricky explanations of different various topics in science and how experienced teachers would teach them, Key Stage 4 to Key Stage 3. Let's get going. Just to know what we'll be doing, I'll just run through all the topics. Key Stage 3, Biology, Natural Selection, Gas Exchange, Nutrition, Digestive System 1, 2 and 3, Photosynthesis, Food Chains and Webs, Living and Non-Living Things, Chemistry, Chemical Formulae, 3-4 Thaw Process, Physical Weathering, Acids and Alkalis 1 and 2, Physics, Static Electricity, Weight and Mass, Types of Energy, Sound Waves, Heat and Temperature. Key Stage 4, Biology, Photosynthesis and Respiration, Chemistry, Greenhouse Effect, Electrical Conductivity of Ionic Compounds, the mole, Reactivity of Group 1 metals, Physics, Density, Electromagnetic Induction, Forces between Objects. Key Stage 3, Biology Natural Selection. Concept. State the concept you are explaining and which key stage the explanation is for. 3. Clear statement of the science at the correct level. Natural selection is a process where organisms that are better adapted to an environment will survive and reproduce. Individuals within a species show variation. There is competition between individuals for resources. Individuals best adapted to the environment will survive. The survivors reproduce and pass on their genes to their offspring. Over many generations, this can lead to the evolution of a new species. Real-life context. Peppered moths. During the Industrial Revolution, pale birch trees became blackened with soot. Dark peppered moths were more camouflaged against the trees than the pale peppered moths, and therefore were more likely to survive and reproduce. Drug-resistant bacteria. Antibiotics provide an environmental pressure. Bacteria which are more resistant to antibiotics are more likely to survive and reproduce. Very topical. Why is this challenging? Students' preconceptions/misconceptions, including references. Students think natural selection takes place as species want or decide to change, and that they determine what features they need to be best adapted. Michael Ferrari, Michaeline, THG, 1998, The Nature of Naive Explanations of Natural Selection, International Journal of Science Education, yada yada. What do experienced teachers say? Students struggle to understand how long natural selection can take and how much this varies among species. Students think fittest means physically strongest, rather than the best adapted to that environment. Explanation. What am I assuming they know? Students may have heard survival of the fittest or the term natural selection before. Students may already be aware that there is a variation amongst animals in one species, e.g. they have seen differences in patterns on animal fur. What will you actually do to explain the concept? How will you take account of student misconceptions? Rather than trying to explain each step of natural selection in detail first, start by briefly explaining the concept and then demonstrating it through real-life examples with activities for students to compete. See Activities section. This way, students can revisit the explanation and apply each step to the example. Students could write out the steps of natural selection with a drawing or diagram from the example next to each stage. If the school has an interactive whiteboard, the Peppered Moths game is great for getting students involved. Where is this game? Hopefully there's a reference. There is. Asking students to create a class mind map with their thoughts on what drives natural selection should help in bringing out misconceptions, e.g., that animals want to change, which can then be discussed and addressed in a class. It is important to explain that environmental pressures are changeable, and this determines which adaptations are advantageous, e.g., what may have given some members of a species an advantage in one environment may put them at a disadvantage in another. Suggestions from experienced teachers. Avoid games which rely too much on imaginary species or concepts that students cannot relate to in real life. It risks students losing sight of the concept. Activities support explanation. Peppered Moths online game. Links there. Students can compete to see who can catch the most moths in each environment. Sticky Dog's Natural Selection Game, TES, a good way to summarize the range of factors that drive natural selection. Points to consider. Advantages and limitations of any model, analogy, practical, etc. Pick one analogy and be aware of any limitations. Make sure you make these clear to students. Analogies which are too far removed from real-life context can cause confusion. For example, I did an activity with a Year 9 group to demonstrate the process of natural selection using Darwin's finches as an example. Students used different beaks, scissors, spoons, tweezers, pegs, etc. to try and pick up different foods, paper clips, lentils, rice, elastic bands, etc. Some students struggled to understand how this linked to the real-life context. Interesting. Let's play the game quickly. Okay, so the Peppered Moths game on Ask a Biologist was actually not there anymore, but they do have a range of other games. I couldn't find one exactly related to what we needed, so I looked up the other link, which is the Sticky Dogs one. And this one I actually played. So what you do is you are told to draw a dog, and you have a choice of different things. So you can have a red dog, brown dog, blue dog, different leg length, different hair length, different tail length, sharp or spiky teeth, flat or grinding. Okay, yeah, sharp and spiky together. Ears pointy or floppy. And then you start off with 10, and then every kind of generation you're told something like, if you have brown, forward eye, or if you have red, double them, or something like that. And there's a range of scenarios here. Here you go. First generation of Sticky Dogs. It's the height of summer, the hottest summer that has ever been, and temperatures are soaring. Sticky dogs with long hair suffer from dehydration. Short-haired, however, roam free and won't get too hot. If you have a long hair, then you lose 3. If you have short hair, then you gain 3, and you carry on. And then they understand the connection, hopefully, between the game they're playing and the concept of natural selection across generations, not within the generation. Let's getting a bit long, so let's pause this one here and come back to this series in a bit.